Okay, what's up, everybody? Happy, whatever today is. We are going to be beginning Unit 7 today. So Unit 7 has everything to do with probabilities. You'll notice that I will have posted a reference page. That is what I have up here on the left over here. This is a good reference that will kind of get you started or give you some hints or ideas about how to get probabilities, what probabilities are, and answer some of the questions that we'll have to answer. Okay, so let's go ahead and get started with our assignment. We have assignment 7.1 today, and what we have is just our general introduction to probabilities. These first two questions, questions 1 and question 2, are in essence asking, is this or could this be a probability? And that references what we have up here at the very tippy top of our reference page is probabilities must be positive, and they also must be less than 1, or AKA 100%. Okay? So probabilities must be positive, and they must be less than 1. So if I take a look at this very first one, which is 3 over 5, so 3 over 5, we see that that is 3 over 5 is the same thing as saying 0.6. So what do I notice about this? I notice that, is it positive? Yes, it's positive. Is it less than 1? Yes, 0.6 is less than 1. So can 3 over 5 be a probability? Yes, it can. All right. So negative 0.05. Okay, that's the same thing as saying negative 1 over 20 if you want to kind of reverse engineer that. Again, we go through the same criteria. Is it positive? And is it less than 1? All right, so I see that this thing is less than 1, but it is not positive. Wah, wah. So no, this cannot be a probability because it has to be positive and less than 1. Okay, next we are getting into more full-fledged probabilities themselves. And in this particular question, the ultimate question is, what is the probability of selecting a blue or a green? Okay, so the chief question of this problem is the word or. Okay, is the word or. So if I take a look at my page on the left here, or in general, okay, is an addition. Okay, don't worry about the word and right now. Or in general is an addition. So I add these probabilities together. All right, so let's take a look here. A jar contains 2 red, 3 blue, and 1 green. What is the probability of selecting a blue or a green? All right, so let's kind of get the rundown. So there's 2 red, 3 blue, 1 green, making a grand total of 6. Okay, there's 6 total there. So what's the probability of selecting a blue or a green? All right, don't worry about the and that's all out of 6. Okay, that's all out of 6. So I add the first probability, the second probability, and again, don't worry about the add, all out of the total. And so this would be 4 out of 6, which is AKA 2 out of 3. That's our fraction in lowest terms. All right, here is a general probability, and I present this deck of cards. I know a lot of people don't completely understand what a deck of cards is and looks like. This is a table of a deck of cards. Note that the total number of cards is 52. So I'm kind of looking at this aspect of the table, okay? This area right here. And so in this problem, we are looking generally, what is the probability of getting an ace? All right, so that's kind of like this, what's the probability of A? Okay, so it would be the number of aces. Aces are this A, and I see that there are 4 total aces. So there'd be 4 out of 52. Okay, 4 out of 52. 4 out of 52 reduces to 1 out of 13. Okay, here they want to know what is the probability of drawing a heart. All right, so here are the hearts, and I see that there are 13 of them. So the probability of heart is 13 out of 52. That reduces down to 1 out of 4. Okay, you're picking numbers between 1 and 20 inclusive. What that word inclusive means is it includes the number 1 and the number 20. So it's not sheerly the numbers between them, you know, like 2, 3, 4, 5, but it also includes 1 and 20. So let me write these out here real quick. I can't quite fit them all right there. Scooch this down just a little bit. So close. Okay, you get the idea. There's 20. So 20 is our total. What's the probability of selecting an odd? So I pick out all the odd numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 out of 20. All right, leave your answer as a fraction in lowest terms. That would be 1 out of 2. Okay, so again, we are picking a number 1 through 20. All right, what is the probability of getting a perfect square? What a perfect square is numbers that are squared. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, etc., etc. These are perfect squares. Okay, so what is the probability if I'm selecting a number out of 1 through 20? What's the probability that I'll randomly select a perfect square? And so that'd be 1, 2, 3, 4. There are 4 perfect squares. So that would be 4 out of 20, which is AKA 1 out of 5. Okay, what is the theoretical probability of rolling anything other than a 2 on a fair six-sided die? So on a die, think of all the different outcomes. You could roll a 1, a 2, a 3, a 4, a 5, or a 6. Okay, so the total number of outcomes is 6. Okay, now let's take a look at what we're looking for. We're looking for a number other than a 2. Other than a 2. So that'd be 1, 2, 3, 4, 5. That would be 5 out of 6. They want a decimal to 3 decimal places. So let's take a look at our calculator here. So 5 out of 6 is 0.8. 3. I'm just going to write this out here. And so if I'm rounding this to 3 decimal places, 1, 2, 3, I notice that this 3 does not round. And so that would be 0.833. Oh, shoot, before I move on. A lot of you are probably really concerned about this quote-unquote theoretical probability. There's 2 different types of probabilities. There's theoretical, and then there's experimental. All right, a theoretical probability is just, pure thought. Okay, it's the pure thought, all right? So without really doing anything, what do you think the probability would be? So for instance, in number 8, we didn't actually roll any die. Okay, we didn't like shoot dice in the corner of the room to get this probability. All we did was just think about the question. Okay, we thought about the question, we thought about the number of outcomes, and I see, oh, there'd be 5 out of 6. This is a theoretical probability, okay, because we just thought about it. Now, if we were to actually, roll a die, and figure this thing out, like actually do this, then that is experimental, okay? Okay, where you actually do what you're trying to do. Like flipping a heads should be 50%. Flipping a heads should be 50%. Okay, but if I flip a coin, 10 times, and let's say I get it to be 60%, that would be an experimental probability. Because I actually did it, and I found my probability is a little bit different. Theoretically, it should be 50%, but my experimental probability was 60%. Okay. What is the theoretical probability of rolling a 3 or 4 on a fair six-sided die? All right, so again, 1, 2, 3, 4, 5, 6 are the outcomes. So there's 6 total different outcomes. What's the probability of getting a 3 or a 4? That'd be 2. So I would get a 2. And so a decimal to 3 places, 2 out of 6 is again 0.333333333. Around it to 3 decimal places, so 1, 2, 3. That is small, so it doesn't round. So 0.333 is what we get. Okay, theoretical probability rolling a 6-sided. Okay, so 1, 2, 3, 4, 5, 6 are my outcomes. So there's 6 total outcomes. Of rolling a 6. So there's only 1 6 out of those 6. And so 1 out of 6 is our probability. So 1 out of 6 as a decimal is 1.1666666. Right, rounding this to 3 decimal places, I see that 6 is a big number, so this is going to round up to a 7. So this is going to be 167 as my answer. And there you go. That's our introduction to probabilities. A probability, by and large, is what you're looking for out of the total. By and large, that's what a probability is. It's what you're looking for out of the total.